Dear children, welcome to this channel. In the previous video, we have seen how to find out the nth roots of a complex number and hence the cube roots of unity and fourth roots of unity. Let us see some problems under that topic in this video. Let us recall the content of the previous video by a keynote. Cos x theta plus I sin x theta is one of the values of cos theta plus I sin theta the whole power x if x is rational. That is, De Moivre's theorem is applicable even if the power is a rational number, but that one, the cos x theta plus I sin theta, if it is rational, power x is rational, it has so many values according to the denominator, and exactly that cos x theta plus I sin x theta will be one among the values. So that is the first one, okay, first point. Now coming to this, that is cos theta plus I sin theta the whole power 1 by n has n distinct values. Whatever the denominator, that much values it will have. So but n distinct values, it will have more than n values. Among that n values will be distinct. Then this is called rotation rule. That is, z e power I theta is a complex number, and this is obtained by rotating this z through an angle theta radians in the anti-clockwise direction. Okay, z e power I theta is represent a complex number where when z is rotated through an angle theta radians in the anti-clockwise direction. And then what will be the nth roots of unity means, the nth roots of unity are represented by 1 omega squared etc. to omega power n minus 1, and what is where omega power n would be equal to 1 again, and omega is equal to cos 2 pi by n plus I sin 2 pi by n. This value is represented as omega. And then what are the properties of the nth roots of unity means, if we sum up all the nth roots of unity, their sum will always be equal to 0. And the product of nth roots of unity will be equal to minus 1 the whole power n minus 1. That is, the product of nth roots of unity will be either minus 1 or plus 1 according to the value of n. And then the arguments differ by 2 pi by n. So omega squared, we will have the arguments differ by 2 pi by n. Omega squared will be cos of 4 pi by n plus I sin 4 pi by n etc. Then 1 plus omega squared etc. omega power n minus 1. They are in a GP with a common ratio omega. So these are the some properties of the nth roots of unity. So in this basis, we can find the cube roots of unity. Then what are the cube roots of unity? 1 omega squared. Then as usual, omega cube will be equal to 1. And then what is omega? Which one is represented as omega? Cos 2 pi by 3. Here it is 2 pi by n, that nth root. And the cube root means 3, so n is equal to 3. So omega is cos 2 pi by 3 plus I sin 2 pi by 3. Also, in the rectangular form, omega is minus 1 by 2. The value of omega in the rectangular form is minus 1 by 2 plus I root 3 by 2, and omega squared is minus 1 by 2 into minus I root 3 by 2. So we have to remember this value of omega and omega squared in case if they are the cube roots of unity, both in the rectangular form as well as in the polar form. So we have to keep the value of omega and omega squared in our memory if they are the cube roots of unity. And then here also the same condition is applied, that is the sum of the cube root of unity is equal to 0. And what are the fourth roots of unity? 1 I minus 1 and minus y. Instead of representing it as 1 omega, it is easy if we remember in this form, that is 1 I minus 1 and minus y. Then what will be the geometrical interpretation of the nth roots of unity? In general, if we nth roots, you know that polar form, if the complex number is in the polar form, how will you represent it geometrically? They will lie on a circle of radius with the radius modulus, with the radius which is equal to modulus, and the center as origin. But here they are the nth roots of unity, the modulus is equal to 1. So all the nth roots of unity will lie in a unit circle with the center as origin. And if we join the points, that is the complex numbers, the nth roots of unity, all these complex numbers, we get a regular polygon of n sides. That if the particularly if they are cube roots of unity means, then the cube roots of unity will form a equilateral triangle. And then fourth roots of unity means they will form a square. because square polygon of 4 sides of regular polygon of 4 sides means that will be a square, regular polygon of 3 sides means that will be equilateral triangle. So in the case of cube root of unity, we have an equilateral triangle, and in the case of fourth roots of unity, the geometrical interpretation, that is, if we join the 4 points, the 4 roots, then you will get a square. Then I would like to tell you one thing. Complex roots always occur in conjugate pairs. So if an equation has one root as complex means the root will not come as a single, it always occur in pair, and the other one will be its conjugate. This is a rule, okay. So for an example, let us consider an equation x cube minus 8 is equal to 0. How will you solve this? In earlier standard, what we will do? You will move 8 out to the outside, opposite side, and we will write 8 as 2 cube, and by taking cube root, we will write x is equal to 2. So this is the way we will obtain the solution for this equation. But as the power is 3, it has 2 more solutions. But that 2 more solutions is not a real number, that 2 solutions are complex numbers. And that 2 complex numbers will always be conjugate to each other. Let us see how to find out the other 2 solutions which are complex conjugate to each other. Now, x cube minus 8 is equal to 0. This x is equal to 2 is a real solution. We are going to find out the other 2 solutions which are complex. Now, take the equation as x cube minus 8 is equal to 0. So, we can write 8 as 2 cube. So, it will become x cube minus 2 cube equal to 0. So, this is in the form a cube minus b cube. So, a cube minus b cube means it can be split up as a minus b into a squared plus ab plus b squared equal, then that is equal to 0. So, equating this factor x minus 2 equal to 0, we get x is equal to 0, that is the real solution. And then equating this factor x squared plus 2x plus 4 is equal to 0, and this is not be factorized. So, applying the formula, x is equal to minus b plus or minus root of b squared minus 4ac by 2a, b is 2, so minus 2 plus or minus root of b squared is 4, minus 4ac, 4 into 1 into 4, that is 16 by 2a, 2 into 1, 2. Then minus 2 plus or minus 4 minus 16 is minus 12 divided by 2. Minus 12 can be split up as 4 into 3, that is 4 comes outside the root as 2 root 3i divided by 2 because it is minus, so I. So, that is a complex number. So, cancelling throughout by taking 2 common and cancelling it with the denominator, we have minus 1 plus or minus root 3i. So, what are the 2 roots obtained in this by solving this factor? Minus 1 plus root 3i and another root is minus 1 minus root 3i. See, they are complex and they are conjugate to each other. So, when an equation has one root as complex, then it won't occur as a single, it will have a pair, with that one is a conjugate to this one. That means complex root always occur in conjugate pairs. Now, let us see the last example of this chapter, complex numbers, that is example 2.36, and this is an important one. Suppose the question is, suppose Z1, Z2 and Z3 are the vertices of an equilateral triangle inscribed in the circle, mod Z is equal to 2, and if Z1 is 1 plus I root 3, then find Z2 and Z3. That is, 3 points are given as the vertices of an equilateral triangle, and that equilateral triangle is inscribed in a circle, modulus is equal to 2. That means that the circle with the radius 2 and the center as origin, and one point Z1 is given as 1 plus I root 3, you have to find out other one. Just now I said that for complex numbers always occur in pairs, okay, for an equation, for a complex equation. Here also we are going to get one point as 1 minus I root 3. Let us see how we have obtained this. Now, consider the points Z1, Z2 and Z3 be represented by 3 points A, B and C in a circle where ABC forms an equilateral triangle, that is given. Now, you know that the angle of an equilateral triangle is 60 degree. So, angle A would be 60, angle B is 60, angle C is 60. Then if we join this with the center, this is center as origin, means if you take that BC as a chord of a circle, this chord subtends an angle 60 degree at the major arc. So, by a theorem, the angle subtended by a chord at the center will be double of the angle subtended at the major arc. So, this is a theorem you have learnt in your earlier standard. So, here the chord BC subtend an angle 60 degree at the major arc, means it will subtend an angle double of it, that is 120 degree here. So, likewise, this if you take the chord AC, again AC subtend an angle 60 degree here in the major arc, means it will subtend an angle 120 degree in at the center. So, this is also 120. Similarly, if we take the chord AB, it will be 60 degree and here it is 120 degree. So, if the point Z1 is represented as A in a circle of radius 2, as it is in mod Z is equal to 2, means this is a circle of radius 2. So, if Z1 represented by the point A in a circle of radius 2 units, then Z2 and Z3 will be obtained at some other Z2 and Z3 by the points on the circumference of the circle such that the angle between them is 120 degree. Okay. So, angle between Z1 and Z2 will be 120 and Z2 and Z3 will be 120 and Z3 and Z1 will be 120 degree, as I explained here. Okay. Now, why I have marked Z2 exactly at this point, that is on, because Z1, the argument of Z1 is 60 degree. So, look at why it is 60 degree. Z1 is 1 plus I root 3. By shortcut method, let us multiply it by 2 and divide it by 2. So, it will be 2 into 1 by 2 plus I root 3 by 2. 1 by 2 is cos pi by 3 plus I sin pi by 3. Pi by 3 means in angle it is equal to 60 degree. So, the argument of Z1 is 60 degree. And then this, you know that the angle between Z1 and Z2 is 120 degree. So, totally it will be 180 degree. Therefore, Z1 should be 120 degree away from Z2, means Z2 must lie on the negative real axis. Okay. And then Z3 here, after 120 degree means it will be here, and this angle is 120 degree, and so it will be 60 degree. So, exactly opposite. That is why I have drawn like this. Okay. So, Z1, Z2, Z3. Now, our work is to find out what is Z2 and Z3. So, I think you have, it is clear why I have drawn such figure and the angle. Now, let ABC be the vertices of the equilateral triangle representing Z1, Z2 and Z3 on the circle of radius 2 and with the center as origin. Okay. Now, as the sides of the triangle subtend an angle 120 degree at the origin, we have Z2 as the rotation of Z1 through an angle 120 degree by the rotation rule. So, we can obtain Z2 by rotating Z1 through an angle 120 degree. Likewise, Z3 can be obtained either by rotating Z2 to an angle 120 degree or Z1 by an angle 240 degree. Okay. So, Z2 as a, therefore, we can have Z2 as a rotation of Z1. And how will you obtain the rotation of Z1 to an angle 120 degree through Z2, means it is obtained by Z1 into e power I2 by 3 by the rotation rule. Similarly, Z3 as the rotation of Z1 into e power I4 pi by 3 or Z2 into e power I2 pi by 3. So, we can obtain Z2 by using this rotation rule, that is Z1 into e power I2 pi by 3. So, Z1 is 1 plus I root 3 and e power I2 pi by 3 is nothing but cos 2 pi by 3 plus I sin 2 pi by 3. Let us find out what is cos 2 pi by 3 and sin 2 pi by 3. Cos 2 pi by 3, it can be split up as pi minus cos of pi minus pi by 3. Therefore, cos pi minus pi by 3 means this lie in which quadrant? Second quadrant. Second quadrant, sin is positive, cos is negative. So, minus cos pi by 3, that is minus 1 by 2 after substituting the value of pi by 3. Similarly, sin 2 pi by 3 is equal to sin of pi minus pi by 3. Sin is positive, so it will be sin pi by 3. Substituting the value of sin pi by 3 as root 3 by 2. We have this one as minus 1 by 2 plus I into root 3 by 2. So, let us multiply these two numbers which are in the rectangular form using the multiplication rule. So, real into real, minus 1 by 2 minus imaginary into imaginary. So, root 3 into root 3 by 2, that is 3 by 2. Then plus I into imaginary into real. So, as it is minus, I have written here, and then real into imaginary, that is root 3 by 2 minus root 3 by 2. Now, this get cancelled. So, minus 1 by 2 minus root 3 by 2 is minus 4 by 2 plus I into 0, that is minus 2. So, what is Z2? Z2 is minus 2. So, according to the figure also, we have marked Z2 exactly on the negative real axis, and then we got Z2 as minus 2. Okay. Now, Z3. So, Z3 can be obtained either by rotating Z1 to 240 degree, that is 4 pi by 3 radians, or by rotating Z2 to 120 degree, that is 2 pi by 3 radians. That is obtained by multiplying e power I2 pi by 3 into Z2, that value. So, Z3 is equal to Z2 into e power I2 pi by 3. Why I have chosen this one means already we have found the value of 2 pi by 3. If we use this one z1 means we have to again find out 4 pi by 3. Instead of that, let us use z2 into e power I 2 pi by 3 because we know the value of cos 2 pi by 3 and sin 2 pi by 3. Now what is z2? z2 is minus 2, just now we have found, and then substitute e power I 2 pi by 3 as cos 2 pi by 3 plus I sin 2 pi by 3 and substitute the values of cos 2 pi by 3 and sin 2 pi by 3 as we found earlier. So by substituting cos 2 pi by 3 and sin 2 pi by 3, we have minus 2 into minus 1 by 2 plus I root 3 by 2. Then multiplying minus 2, we will have plus 1 and then minus into plus minus and 2 and 2 get cancelled, I root 3. So z2 is 2 minus 2 and z3 is equal to 1 minus I root 3. So z2 is nothing but exactly the conjugate of z1, so which exactly lies in the opposite quadrant. This is an important problem. This is an important 5-mark problem. Now let us do this, see some exercise problems. Exercise 2.8. First one, if omega not equal to 1 is a cube root of unity, show that a plus b omega plus c omega squared by b plus c omega plus a omega squared plus a plus b omega plus c omega squared by c plus a omega plus b omega squared is equal to minus 1. See, whenever you come across the word w is not equal to 1 is a cube root of unity, w is a cube root of unity like this, immediately you can write omega cube is equal to 1 and 1 plus omega squared is equal to 0. So, we are going to use this during the execution of the problem often. So, whenever you have seen omega cube root of unity means remember the two conditions as omega cube is equal to 1 and 1 plus omega squared equal to 0, that is sum of the cube roots is equal to 0. Now we will use wherever it requires, right? Now take the given expression a plus b omega plus c omega squared by b plus c omega plus a omega squared and then multiply it with omega. Multiply the numerator and denominator by omega, and then the second part of the expression a plus b omega plus c omega squared by c plus a omega plus b omega squared by omega squared. Okay, multiply the numerator and denominator by omega squared. Now keep the numerator as such and multiply in the denominator, multiply omega inside the bracket. So what happened? B omega plus c omega squared plus a omega cube. Likewise, keep the numerator as such and multiply omega squared inside the denominator. So it will become c omega squared plus a omega cube plus b omega power 4. Now again, don't disturb the numerators, let us simplify the denominator alone. Now look here, b omega cube, you know that omega cube is 1, so it will become a plus b omega plus c omega squared. And here a omega cube is 1, so it will be a, and then what is omega power 4? Omega power 4 can be expressed as omega cube into omega. Likewise in the power of I, here wherever as omega is a cube root of unity, omega has a higher number, that is number higher than 3. What you have to do, split this as multiples of 3 and then leave that multiple of 3 and take the remainder, that will be the value of the given one. So whenever you have power other than 3, so divide it by 3 and take the remainder. Likewise in the complex imaginary number I, there we use 4, but here as it is a cube root of unity, you have to express it as a multiple of 3. So omega power 4 can be expressed as omega cube into omega cube being 1, it will be equal to omega. So b omega power 4 is simply b omega and then c omega square. Now if you can see this, the numerator and denominator get cancelled as they are equal. So what is the remaining term? Here in the first term you have omega and the second term omega square. So omega plus omega square. And then whenever you have seen omega plus omega squared, immediately you have to remember this condition. 1 plus omega squared is equal to 0 implies omega plus omega squared is equal to minus 1. So you can use this condition wherever such a term occurs. 1 plus omega means you can replace it by minus omega squared. Omega plus omega squared means you can replace it by minus 1, or 1 plus omega squared means you can replace it by minus omega. So with this condition we can replace the sum of any two terms by the negative of the third one. So omega plus omega squared can be expressed as minus 1. So you have proved that the expression, the value of the given expression as minus 1. Then fifth problem is solve the equation z cube plus 27 is equal to 0. See, likewise in the previous video we did an example sum with the 8i. So in the same way we are going to do this problem. So given z cube plus 27 is equal to 0, first of all you have to move the numbers to the opposite side and then write the number numerical value alone and then write the sign minus I or anything with inside the bracket. So here this is the way to do such a problem. So here we have minus 27. So write the numerical number 27 alone outside and remaining minus 1 here. So as in the within the bracket and then take a cube root on both sides. So what you will have z is equal to cube root of 27 is 3 and minus 1 to the power 1 by 3. So that means that we are going to find out cube root of this number minus 1. So let us express this minus 1 in the form of polar form. So we can write it directly as cos pi is minus 1 and sin pi is 0, and therefore directly we can write it as cos pi plus I sin pi. Now applying the before applying the power de Moivre's theorem, that is 1 by 3, we have to write down this is the principal argument, so we have to write down the general form by adding 2k pi. So pi plus 2k pi plus I sin pi plus 2k pi the whole power 1 by 3, where k is equal to 0, 1, 2, 3 etc. Here k can take any value, it is not restricted. After applying the value 3, 1 by 3 as by de Moivre's theorem, the value of k gets restricted to 0, 1, 2, because even if you substitute 3, 4, you will get the same 3 values. So the values of k is restricted. So for these 3 values we have a distinct value. For other values the same values will be repeated. Therefore k has been restricted to 0, 1 and 2. The power is 3, so only 3 values starting from 0, 0, 1 and 2. Then by substituting k as 0, 1 and 2, we will have the 3 values. That will be the solution of the given equation. Therefore, let us see what would be the 3 roots of the given equation. The 3 roots of the given equation are when k is obtained by when substituting k is equal to 0, 1 and 2. So when k is equal to 0, it will be 3 cos pi by 3 plus I sin pi by 3. That is cos pi by 3, you know the value. As the angles pi by 3, like that, if it is 60 degree or a multiple of 60 degree or 30 degree, we can substitute values. If it is some pi by 12, pi by 18, pi by 7 like that, we can leave as such. Okay. So as the angle is a specific angle and its value can be known, we can replace it by its value so that it can be expressed in the rectangular form too. So cos pi by 3 and sin pi by 3 can be replaced by their values, and then after substituting the values it will become 3 into 1 by 2 plus I into root 3 by 2. Now this is one root. What is the second root? By substituting k is equal to 1. So 2 pi plus pi 3 pi. So 3 pi by 3 means 3 and 3 get cancelled pi. So 3 into cos pi plus I sin pi. Again pi as a known value, so we can substitute the values and then we can rewrite this in the rectangular form. Cos pi is minus 1 and sin pi is 0. So 3 into minus 1, that is equal to minus 3. Then the third root is obtained by substituting k is equal to 2. So 2 2s are 4, 4 pi plus pi, 5 pi by 3. Again 5 pi by 3 can be split up as 2 pi minus pi by 3. 3 2s are 6, 6 minus 1 is 5. So 2 pi minus pi by 3. So cos 5 pi by 3 is equal to cos of 2 pi minus pi by 3. 2 pi means one complete rotation. So minus pi by 3 means that angle will lies in the fourth quadrant. In fourth quadrant cos is positive. So cos pi by 3. And then what is cos pi by 3? 1 by root 2. And sin of 5 pi by 3 means sin will take negative. So minus sin pi by 3, that is minus I root 3 by 2. So these are the 3 roots of the given equation. Now you can see that among the 3, one is real and other 2 are complex, and both the complex numbers are conjugate to each other. See, they are conjugate to each other. So whenever the complex root occur, always they will occur in pair, that is they are occur in pair which will be conjugate to each other. Next, sixth one. If omega not equal to 1 is a cube root of unity, show that the roots of the equation z minus 1 the whole cube plus 8 is equal to 0 are minus 1, 1 minus 2 omega and 1 minus 2 omega squared. Here we are going to do this in a different way, that is z minus 1 cube the whole cube plus 8 is equal to 0. Let us move this 8 to opposite side as usual. So z minus 1 the whole cube is equal to minus 8. Now I am going to split this as, instead of taking the numerical value alone and minus 1 as like in the previous problem, instead of doing like that, I am going to take minus 8 into 1. Now taking cube root on both sides to remove this, z minus 1 is equal to minus 8 to the power 1 by 3 into 1 to the power 1 by 3. So minus 8 to the power 1 by 3 means cube root of minus 8 will be minus 2. So minus 2 into 1 to the power 1 by 3. Now what is 1 to the power 1 by 3? This is nothing but cube root of unity. So let us, but a cube root of unity means we know that the three roots are 1 omega and omega squared. Therefore z minus 1 will be equal to minus 2 into 1, or z minus 1 will be equal to minus 2 into omega, or z minus 1 will be equal to minus 2 into omega squared, as 1 power 1 by 3 has these three values, z minus 1 have three values. Okay. And therefore z is equal to minus 2 plus 1, which is equal to minus 1, and here z minus 1 equal to minus 2 omega means z is equal to 1 minus 2 omega, and here moving this one we have z is equal to 1 minus 2 omega square. Therefore the roots of the equation are minus 1 and 1 minus 2 omega into 1 minus 2 omega square. Then seventh one, find the value of sigma k is equal to 1 to 8 cos 2k pi by 9 plus I sin 2k pi by 9. See here, look at the denominator, it is 9. Okay. So if you take k, what will be? It will become cos 2 pi by 9 plus I sin 2 pi by 9. That will be one of the ninth root of unity. So let us consider the ninth roots of unity. So what are the ninth roots of unity? They will be 1 omega, omega square, etc. to omega power 8. And what would be the value of omega? Cos 2 pi by 9 plus I sin 2 pi by 9. So as they are given here 9, we are going to take the ninth roots of unity as 1 omega, omega square to omega power 8, where the omega value of omega is cos 2 pi by 9 plus I sin 2 pi by 9. You know that whenever the roots of unity are given, the sum of the all roots of unity will be 0, equal to 0. So likewise here the sum of all the nth roots of unity will be equal to 0. So 1 plus omega square plus etc. omega power 8 is equal to 0. Now moving this one to opposite side, we have the sum of the ninth roots of unity as omega plus omega square plus etc. to omega power 8 is equal to minus 1. So this is nothing but sigma k is equal to 1 to 8 omega power k. Now what is omega? 2 pi cos of 2 pi by 9 plus I sin 2 pi by 9. So let us replace omega as cos 2 pi by 9 plus I sin 2 pi by 9 the whole power k. Now applying the de Moivre's theorem, k is to be multiplied. So this is sigma k is equal to 1 to 8 cos 2k pi by 9 plus I sin 2k pi by 9 is equal to minus 1. And this is the value of this one is required, and this one is equal to minus 1. So in the same problem, suppose instead of 9, some 10 or 11 are given, you have to take 11th roots of unity. If it is 9, 10 are given, you have to take 9th root of unity. So as 9 is given, I have taken 9th roots of unity. So in the same way, you can do the problem according to the number given. Now let us see the 8th one. If omega not is equal to 1 is a cube root of unity, show that 1 minus omega plus omega squared the whole power 6 plus 1 plus omega minus omega squared the whole power 6 is equal to 128, and 1 plus omega into 1 plus omega squared 1 plus omega power 4 into 1 plus omega power 8 plus etc. to 1 plus omega power 2 power 11 is equal to 1. So I said that when it is given omega is a cube root of unity, immediately you have to write two results, that is omega cube is equal to 1 and 1 plus omega squared is equal to 0. So you have to use these two results wherever necessary, and then even you can take 1 plus omega, whenever you have 1 plus omega squared in the execution of the problem, you can replace it by 0, or you have 1 plus omega, you can replace it by minus omega squared, or omega plus omega squared, you can replace it by minus 1, or 1 plus omega squared, we can replace it by minus omega. So whenever you see omega as a cube root of unity, you have to write these two conditions, and we have to use wherever necessary. Now let us do the first subdivision. What is the first subdivision? 1 minus omega plus omega squared the whole power 6 plus 1 plus omega minus omega squared the whole power 6. Now how we are going to simplify this? Now look at 1 plus omega squared minus omega. We can rewrite this as 1 plus omega squared minus omega, and 1 plus omega squared can be replaced by minus omega from this condition. So 1 plus omega squared is equal to minus omega. So we can replace 1 plus omega squared by minus omega. Already we have one minus omega here. So this first term has become minus omega the whole power 6. So why we are doing this? In order to simplify this, we are replacing the values by this condition. Now look at the second term. We have 1 plus omega. So let us replace it by minus omega square to make it as in the simplified form. So 1 plus omega can be replaced by minus omega squared. Again from this condition, 1 plus omega squared is equal to 0. Now this will become minus 2 omega the whole power 6, and this become minus 2 omega squared the whole power 6. So minus 2 the power 6 is 64 and omega power 6. Here also minus 2 whole power 6 is 64 and omega power 12. Now as omega is a cube root of unity, if the power is other than 3, what is the rule? You have to divide it by, you can divide it by 3 and you can find out the remainder. Now exactly 6 and 12 are exactly multiples of 3. So the value will be equal to 1. So omega power 6 is 1 and omega power 12 is also equal to 1. So 64 plus 64, that is equal to 128. So you can see here. Omega power 6 is omega power 3 the whole square. It is a multiple of 3, and omega power 3 being 1, it is also equal to 1. Likewise, omega power 12 is a multiple of 3. 3 into 4, and then it is 1. So 1 power 4 is again 1. So whenever omega is a cube root of unity, and when the power is other than 2 or 1, divide it by 3 and then take the remainder. Okay, and if it is exact multiple of 3 means the value will be equal to 1. Now coming to the second subdivision, 1 plus omega into 1 plus omega squared, 1 plus omega power 4, etc. to 1 plus omega power 2 power 11. You have to find out the product. Now the first two terms write as such, and here see omega power 4, it is power is more than 3. So more than 3 means what you have to do? You have to divide it by 3 and take the remainder. So on dividing it by 3, the remainder will be 1. So it will be 1. Again we can write it as 1 plus omega. Omega power 8. So it can be written as 6 plus 2. Again omega power 6 being 1, and then the remainder is 2. That is omega squared, 1 plus omega squared. Likewise, if we write down the other two terms, so you will have how many terms? Up to 12 terms you will get 1 plus omega squared, like that you will up to 12 terms. So this will get repeated up to 12 terms. Why it is 12 terms? Here starting with this 1, the power of 2 is 1. And then here 4 means the power is 2 squared, and here it is 8, that is 2 cube. So up to 2 power 11. So how many terms it will be there? There will be 11 terms, and this one is 1, addition this one is 1. So totally how many terms will be there? 12 terms. So the same term, 2 terms get repeated, that is 1 plus omega squared will get repeated. Up to how many terms? 12 terms. So we can write it simplified. The product can be written as 1 plus omega into 1 plus omega squared the whole power 6. So 1 plus omega 6 times and 1 plus omega squared 6 times. So totally the product has been now 1 plus omega into 1 plus omega squared the whole power 6. Now let us simplify this, then after we will take the power 6. So let us multiply 1 into 1, 1 into omega, and then 1 into omega squared, omega into omega squared, omega cube. Again omega cube is 1, so replace it by 1, and then 1 plus omega squared, when you see the sum of the 3 terms, it will be equal to 0. So 0 plus 1, that is 1 power 6, that is equal to 1. So we have proved the result, the product is equal to 1. Then ninth one, if z is equal to 2 minus 2i, find the rotation of z by theta radians in the counterclockwise direction about the origin when theta is pi by 3 and when theta is 2 pi by 3 and theta is 3 pi by 2. So here we are going to do the rotation rule in order to do this problem. See, given z as 2 minus 2i. So if it is in the polar form, then it is easy to rotate this through an angle. Pi by 3 means we can multiply z into e power I pi by 3. So when z is in the polar form, it is easy to multiply. So let us convert z to the polar form. So to taking 2 outside, it will be 1 minus I. So by shortcut method, I have multiplied and divided by root 2. So 2 root 2 into 1 by root 2 minus I by root 2. So 1 by root 2 is nothing but cos pi by 4, and here 1 by root 2 is sin pi by 4 with the sign minus. So involve this minus sign inside. So cos of minus pi by 4 plus I into sin of minus pi by 4. So cos minus pi by 4 and I sin pi by 4 is nothing but e power minus I pi by 4. So z is now written as 2 root 2 into e power minus I pi by 4. So we have used the Euler form for simple calculation. Okay. Now first you have, let us do the first subdivision. When z is rotated through an angle pi by 3, what would be the value of z? So when z is rotated through an angle pi by 3, the value of, let us take that one, the new position to be z1, and it is obtained by the rotation rule as z into e power I pi by 3. That is multiplying this z with e power I into this angle pi by 3, the angle through which z is rotated. What is z? Z is 2 root 2 into e power minus I pi by 4 and into e power pi by 3. So they are, the bases are same, the powers are to be added, and taking I outside, pi by 3 minus pi by 4. Under simplification it will become pi by 12. So what is the new value of position of z after rotating through an angle pi by 3? It is 2 root 2 into e power I into pi by 12. Now similarly let us do the second subdivision. So what is, in this case theta is 2 pi by 3. So when z is rotated through an angle theta, that is 2 pi by 3, let us take that complex number to be z2. So that is obtained by multiplying z with e power I into 2 pi by 3, this angle. So what is z? 2 root 2 into e power minus I pi by 4 and then e power I into 2 pi by 3. Again adding the powers, being the base same, adding the powers, taking I common, 2 pi by 3 minus pi by 4. So under simplification it will become 5 pi by 12, that is taking LCM 12, and here you have to multiply it by 4, 4 2 is 8 and here 3, so 8 pi minus 3 pi, that is 5 pi by 12. Then third subdivision, in this case angle is given as 3 pi by 2. So when z is rotated through an angle 3 pi by 2 radians, then the new position of z will be represented by z3, and it is given by z into e power I 3 pi by 2. Replacing the value of z as 2 root 2 into e power minus I pi by 4, and then multiplying these two, we have to add the powers. By adding the powers, I is taken common outside, and 3 pi by 2 minus pi by 4. Again taking LCM, and 2 is to be multiplied, 6 pi minus pi, 5 pi by 4. So what is the new value of z? That is z3 is equal to 2 root 2 into e power I into 5 pi by 4. So in all these problems we have used a rotation rule. Then 10th one is, prove that the value of 4th root of minus 1 r plus or minus 1 by root 2 into 1 plus or minus I, not 4th root of 1, 4th root of minus 1. Okay. So let us take this one, whose 4th root r is to be find out as z. So let us take z is equal to minus 1 the whole to the power 1 by 4. So moving this 4 here, z power 4 will be equal to minus 1. Let us write this minus 1 in the polar form, and you know that cos pi is minus 1 and sin pi is 0. Here there is no imaginary part. So this can be written directly as cos pi plus I sin pi. So pi being the principal argument, let us write in the general form by adding 2k pi. So cos of pi plus 2k pi plus I sin pi plus 2k pi, where k can take any value from 0. This is z power 4. So to get z, we have to take 4th root on both sides. So z is equal to cos pi plus 2k pi plus I sin pi plus 2k pi, the whole power 1 by 4. And then applying the De Moivre's theorem, that means 4 is multiplied with the argument. We have cos of pi plus 2k pi by 4 plus I sin pi plus 2k pi divided by 4. Now after taking the De Moivre's theorem, the value has been restricted to the k to only 4 values, that is k is equal to 0, 1, 2, 3. The value of k is restricted, because after this 4 values, the fifth one again they will get repeated. So these are the distinct values. Now what are the 4 roots? By substituting k is equal to 0, 1 and 2 and 3, we have 4 different values. Now let us see what are the 4 roots are. When k is equal to 0, z will be cos of pi by 4 plus I sin pi by 4. Cos pi by 4 is 1 by root 2 and sin pi by 4 is 1 by root 2. So we can rewrite as 1 by root 2 plus I into 1 by root 2. As pi by 4 is a known angle, we can replace its value and write z in the rectangular form also. Then when k is equal to 1, z will be 2 pi plus pi, 3 pi by 4 plus I sin 3 pi by 4. So what is 3 pi by 4? We can write it as, split it as pi minus pi by 4, that is 4 minus 1 is 3, so pi minus pi by 4, and here also split it as pi minus pi by 4. Now pi minus pi by 4 means this angle lies in which quadrant? Second quadrant. Second quadrant, both cos and sin are negative, so minus cos pi by 4, sin is positive and cos is negative, so minus cos pi by 4 plus I sin pi by 4. Pi by 4 again replacing the value, for cos and sine, we have minus 1 by root 2 plus I into 1 by root 2. Now, by substituting k is equal to 2, the other third value is z is equal to 2 2s are 4, 4 plus 1 5. So, cos pi 5 pi by 4 plus I sin 5 pi by 4. Again, this is 4 1s are 4, 4 plus 1 is 5. So, we can write pi plus pi by 4, I sin pi plus pi by 4. In this case, this angle pi plus pi by 4 lies in the third quadrant. In third quadrant, both cos and sin are negative. So, we have minus cos pi by 4 minus I sin pi by 4. Again, replacing the value of cos pi by 4 and sin pi by 4, we have z as minus 1 by root 2 and minus I into 1 by root 2. Now, the last fourth value is obtained by substituting k is equal to 3. So, z is equal to, it will be by substituting k as 3 here, 2 3s are 6, 6 plus 1 7. So, it will become cos 7 pi by 4 plus I sin 7 pi by 4. Again, let us split that, 4 2s are 8, 8 minus 1 is 7. So, 2 pi minus pi by 4, and then here also sin of I into sin of 2 pi minus pi by 4. 2 pi means after one complete revolution, 2 pi minus pi by 4, the angle will lies in the fourth quadrant. In fourth quadrant, cos is positive and sin is negative. So, it will become cos pi by 4, and here it is minus I sin pi by 4. Again, replacing the values of cos pi by 4 and sin pi by 4, you will get the fourth value as 1 by root 2 minus I into 1 by root 2. So, what are the 4 roots of the given equation? The 4 roots of minus 1, that is the 4 roots of minus 1 the whole power 1 by 4 are 1 by root 2 plus I into 1 by root 2, minus 1 by root 2 plus I into 1 by root 2, and then minus 1 by root 2 minus I into 1 by root 2, 1 by root 2 minus I into 1 by root 2. So, these are the 4 values, but according to the question, we have to rewrite in this form. The 4 roots can be rewrite in this form. Okay. So, these are the 4 roots, and we are going to rewrite the 4 roots according to the question, according to the form which is asked in the question. So, what we are going to do, we are going to combine the first one and the last one, that is the real is positive and here the imaginary parts are negative. So, we can write it as 1 by root 2 plus or minus I into 1 by root 2. So, the first and the last has been combined like this. Similarly, the second and the third, here both the real part are minus and the imaginary parts have different signs. So, they can be combined and written in the form minus 1 by root 2 plus or minus I into 1 by root 2. Again, here the imaginary parts being the same and the real part has a different sign. Again, these two can be rewritten as plus or minus 1 by root 2 plus or minus I into 1 by root 2. Then taking 1 by root 2 common outside, that is plus or minus 1 by root 2 outside, we have 1 plus or minus I. So, we have rewritten the 4 roots in the form which has been asked in the question.